Top-down design. In this video, we will be seeing programming and implementation issues, system design techniques, programming techniques, modular designs of a program, top-down design, and stepwise refinement. Programming and implementation issues. We know that if we have a problem, we will solve it by writing a program. To write a program, we need a programming language. And we have seen what a program and a programming language is. A program is a collection of instructions that performs a specific task when executed by a computer. And a programming language is a computer language designed to communicate instruction to a machine. System design techniques. Sequence of computational techniques to solve a problem is called system design. We mainly follow two types of system designs, top-down design and bottom-up design. What is top-down design? If a big problem is divided into a number of small problems and each sub-problems are again divided into sub-problems and we solve them one by one. Such an approach is called top-down design. It is best suited for solving big problems. How does it work? The main program is written first and tested before the subprograms are written. Then all the subprograms will be written and each are tested separately. And a simple main program is written to test the subprogram. It is not the main program which I have mentioned already. If it runs successfully, then the subprograms are tested with the main original program. If the whole program will run successfully, then write it and recheck it. This is how the top-down design works. Bottom-up design is the opposite of the top-down approach. Here the basic subroutines or all the subprograms are written first and these subroutines are combined together to make the complex program. C follows top-down approach. Programming techniques. There are two techniques for programming, linear programming and structured programming. In linear programming, we don't have any decision making. It is similar to sequential programming. What is structured programming? It includes both conditional, branching and looping. It helps to reduce errors in writing complex programs. Here the whole program is broken into submodules and the programs can be written easily and quickly. It is easy to debug and the productivity is also high. Basic constructs of structured programming. There are three constructs in structured programming. They are sequence, selection and iteration. In sequence, it's a continuous set of actions where one is followed by another till the expected result is obtained. We have seen if the statement 1, 2, 3, etc. are executed one by one, it is called a sequence. There is no conditional or branching or looping here. Selection. It is used in conditional execution. When you take some action based on the results of logical test, that is a selection construct. So we have seen if-else statements. If will be giving certain condition and if the condition is true, true statements will be executed. Otherwise, false statements will be executed. Iteration. Iteration is repetitive execution of consecutive instructions. It is also called as looping. It may either be conditional or unconditional looping. Conditional looping means certain set of conditions will be executed repeatedly until a particular condition is met. In unconditional looping, there won't be any condition, but the statements will be executed repeatedly n number of times. We can represent the basic constructs like this: the sequential flow, conditional flow, which is there is a condition and there will be two branches over here, and a loop. Modular designs of a program. Each program consists of various modules and each module performs separate functions. We always specify certain requirements for the modules in a modular design. So the requirements are coupling, cohesion, span of control, size, and shared use. What is coupling? It means how modules or how subroutines or how subprograms are strongly related to each other so that if you do change in one module, it will not affect other modules much. That means the coupling should be minimized in a program. There should not be much relation or much interaction between the submodules. Cohesion. It indicates the strength of relations within the module. For an ideal design, cohesion should be maximized. That means the relationship between the variables and data and function inside a particular module should be maximum. Next is span of control. An individual module may be called a fixed number of subordinate modules. A module can call a number of submodules. So the number of submodules connected to a particular module is called the span of control. Next is size. We always recommend that the module size should be small so that the number of instructions within a module is also limited. It would be easy to manage and debug. Shared use. For modular design, each module within that program is accessible by other modules. You should not use duplicate function for separated modules, but you can invoke a function from one module to any other module if required. Next topic is top-down design and stepwise refinement. We have discussed what is top-down design. There will be a main task, the main problem to be solved. For simplicity, we will divide the main task into subtasks. Subtask 1, 2, 3, etc. Again, each subtask can be subdivided into smaller subproblems, submodules. Then we will start solving from the lowest level submodules and finally we will combine together to get the solution for the main problem. Now what is stepwise refinement? Here also we will successively divide the complex problems into simpler subproblems and if required again the subproblems will be divided into simpler ones. Some of the tasks may themselves need subdivision and some may not. This process is called stepwise refinement or decomposition. In this figure, you can see initially we have only one operation to do, go home. When we expand that step, we can see there are three submodules. So go home is a module. We are dividing the task into three subtasks. Leave home, drive home, and arrive. Again, if we divide, we will be getting some more modules added. So likewise, after each step, we will be getting smaller submodules. Upon solving each submodules, we will be reaching the solution to the main problem. This is called as stepwise refinement. The whole stepwise refinement process can be said like this, can be illustrated like this. The first stage is informal representation of the problem. Mathematical model, that is, we will represent the problem using any mathematical model like tree or a graph and we will write it in simple informal English language like pseudocode. Then the next step, here is the main or formal algorithm design stage. We will convert our informal algorithm into a formal algorithm which may include the syntax and semantic. After this comes the real implementation. The program implementation phase where we define the abstract data types and write the procedures for the various operations using prescribed programming language. So that's all about the top-down design. and stepwise refinement. Thank you.